So we want to find out the area of the inner loop of r equals 2 plus 4 cos theta. So let's have a look at this then. Here's the area here, but let's do a sketch of it to be sure where the inner loop is and what bounds we need to use. So if we put 0 down for starters, cos 0 is 1, so we'll end up with 6, which is the biggest radial value. At 0, we get a value 6. Then you can see that as we go around to pi over 2, this will tend to 0, because cos 90 is 0, and it will go down to 2. So that's good. So it goes around and down to 2. Now when will it get to 0? So when is that 0? Well, that's 0 when this cos theta is equal to minus a half. So the question is, when is cos theta equal to minus a half? So if we think about cos alpha equals a half, the associated acute angle. So let's draw a line here. Oh, I'll try and draw it better than that. A solid line I'll draw. So we'll go out here. And cos alpha is a half. Cos 60, isn't it? So this angle, this associated acute angle, will be 60. So here, cos at 2 pi over 3 then, or 120 degrees. We know that cosine is negative in this quadrant. Cos 60 is a half. So this will be minus a half, and that will give us 0. So this comes around and goes down to 0 here, doesn't it? Like so. Then it's symmetrical on the other side, so you can just draw the same shape the other side. So we're interested in this whole shape, which is symmetrical. So we can just do 2 of these then, can't we, basically? Yeah, that's fine. So all we're interested in then is from 0 round to 120 degrees. So let's do that then, and it's 2 lots of course. So here, the area A equals 2 lots of the half will just cancel each other out, and then we'll get 0 to 2 pi over 3, isn't it? Of r squared, 2 plus 4 cos theta squared. Squared d theta. There we go. So let's just double check that. 0 round to 2 pi over 3 of r squared, yeah, d theta. 2 lots of that, so the half will cancel. So that's equal to then between 0 and 2 pi over 3 of this squared, which is 4. 2 4s are 8, and there's 2 terms in the middle, so that's 16 cosine theta plus 16 cos squared theta d theta. This is equal to then, well, here we've got just the integral between 0 2 pi over 3, 4 plus 16 cos theta plus, now this will be 8, and the 2 cos squared theta can be replaced by cos 2 theta plus 1 from the double angle formula. Yeah, agreed. So all I did was took out an 8 there and left one of the 2's with the cos squared. 2 cos squared is none other than cos 2 theta plus 1, the double angle formula. So now we can integrate. Don't forget there's a 4 here, and then when you expand the bracket there's an 8 there. So in a sense you've got 12. 12 integrates to 12 theta. 16 integral of cos is sine. 16, that's supposed to be there. Let me just tidy that up while we're at it. That's 16. Now we've got 8 cos 2 theta, so that integrates to sine 2 theta. A 2 will come out to make the 8, so we just need a 4 there, don't we? With a plus. So that needs to integrate in between 0 and 2 pi over 3. So what do we get then? So we're going to get, let's put the values in then. It's the top value, take the bottom value. So the nice thing is when you put 0 in here, here, and here, the second terms will be 0. So we can put that in already. Now we just need to put the top terms in, the 2 pi over 3 here. 12 times 2 pi over 3. 12 times the 2 pi over 3 then. Plus 16 sine 2 pi over 3 plus 4 sine 4 pi over 3. Okay, so let's work out that then. This is 3 goes into 12 4 times, so we're just left with 8 pi. 16 sine 2 pi over 3 is sine 120. So let's just type in that, sine 2 pi over 3. We'll use degrees because 120 is a lot easier to write in the calculator. So I'll flick over to degrees, shift mode, and I'll put degrees. And then I want to work out 16 sine 120. So 16 times sine 120. And then it's plus 4 times sine, and it was two lots of this, so it's 240, isn't it? So 240 degrees. So I've used degrees because it's easier to type them out. Plus 6 root 3. So there's the answer. 8 pi plus 6 root 3. 8 pi plus 6 root 3 units squared is the area for that shape.